Hey guys, so in today's video we're going to be going over Anki again and pretty much just going over really whatever the flashcards throw at us. Yesterday what I went over was some Pandas data frames. We're working with the Titanic training dataset, the summer dataset, and both of these datasets can be found in Kaggle. Just type in Olympic dataset Kaggle in your search and then you should come across summer, and you could just download the summer one, and then Titanic. You just type in Titanic Kaggle and you should be able to download it. So yesterday what we went over is we went over pd.to numeric, and all pd.to numeric will do is it'll check values. Well, in essence, it'll go ahead and evaluate the column and then identify integers. And if there are errors, meaning if there's no integer value, but if there's like a string value in your column, essentially this, then what it'll do is it'll go ahead and do whatever the error reports to do. And what I mean by that is, since we're using errors equals chorus, it'll go ahead and transform like the string into a nan or null value. So I always say nan or null. I should just pick one, but yeah, anyways. Next up, what we were working with is we were just pretty much working with like pd.locate. So identifying a specific value in a specific column, and then returning, in essence, this same row that has like this value. So for example, this row, which is row 1, or yeah, I guess we could call that index of 1, row 1. But what it does is it identifies where it says male, and then so long as that row has male in the sex column, then it'll go ahead and return the fair, which is another column, another value. So think of it like identifying all the males that paid for their trip on the Titanic. That's what we're returning. Next up, we also used the length for identifying unique values. You can do that with dataframe.age.unique, and this will identify all unique values in the age column. Likewise, so too will this. This value will go ahead and count the number of numeric values in the age column. And then finally .columns, and we're also looking at the data types. And then this little squiggly as well. But the two things I did want to go over is nsmallest and then concatenate, and then we'll move on to the flashcards. So the reason though that I'm revisiting these is because the more that we revisit them, the better we'll get. Feel free to skip to whenever we start doing the flashcards. But just as a recap, nsmallest will go ahead and return the number of rows. So n just equals the number of rows that we want to return, and we decide to select 2. And then we want the smallest, because of this, we want the smallest columns, or the smallest values in the age column. And then that's why we have an age of 0.16 and an age of 0.4. So again, rows, the column that we're selecting, and then just the smallest values. And then it just pretty much like a small youngest, second youngest, third youngest, and so on. And finally, when it came to concatenate, so if you remember yesterday, when it comes to concatenation, what you'll do is you'll take a certain portion of the data, and then you'll go ahead and take another portion of the data, and then you'll kind of like stack them on top of each other in a vertical sense. And all we're doing is we're selecting, in our example, the summer data set, and we're selecting the year that is equals to 1904, and we're going to have that first saved as a data frame here. We're going to select 1908 and 1912, and then when we concatenate them, what we'll have is we'll have 1904, in the middle will be 1908, and then the bottom will be 1912. And then from there, we also did a final concatenation just to add a little more, information that will be useful whenever you work with data. So in essence, we're doing the same thing with this this output, but what we're doing is we're going to go ahead and work with a hierarchical tier of the data. And what I mean by that is everything from the year of 1904 will have 04, everything from the year of 1908 will have 08, and everything from the year of 1912 will have the number 12. So again, we'll just have this 4 for all of the rows, and they're all correlated to this specific value. And likewise, so too, every year that's 1912 will be correlated to 12. And then we pretty much just renamed the names for year right here, and then as well as the original index. So let's go ahead and run the data one more time, so then we could just dive right into working with it. And we need to, I didn't change my directory, so let's go ahead and first change the directory. What would it be? I believe it would be content, drive, my drive, and then I believe it'd be Kaggle. Yep, try it one more time. Okay, perfect. So now that we're in the proper directory, what I'll go ahead and do is we'll go ahead and dive into some of the flashcards. So because some of these will be reviewed for myself, I'm going to quickly go through them. Feel free to pause the video and answer the question of how you would address the question with pandas. So for example, how can you convert a columns data that's okay, how can you convert a columns data type to another data type, if that makes sense. So in essence, how can you convert an integer to a string? And we want to convert every value in the in one specific column to a string. So how would you convert them to a string? So what you would do is we'd go ahead and take df. Oh, we're at the top. I would take data frame and then select my column. So like for example, we do dataframe.age, and then we do as type, and then do we do str? The reason I'm hesitant on what I just did when I said str is because float 64 and place equals true is because I'm not certain if it is actually a string or if it is like an object. But when in doubt, we'll go ahead and flip the flashcard. Yeah, let's flip the flashcard. But I know we would use as type. So again, these are as much practice for myself as it would be for yourself. So let's see. So what we would do is we'd go ahead and save the value. So we would take the data frame and then the column, and then we go ahead and say dataframe.column or dataframe column dot as type, and then it'd be date times 64. And in our case, what it would be is it should be object. So if we were to go ahead and copy this over and then mimic the output, so again that's object, and what we would do is we do dataframe.age equals blank, and then we go ahead and convert it, and now it would be an object. So what I did before was I did in place equals true because I thought that you can use that for the .as type, but it, as we see right here, doesn't allow for it. So that's how you convert a data type for a specific column. So I'm going to remember as type for sure. I'll go ahead and select hard so that way I can see it in 2 more days and get some more practice. Next, let's see what this question is, or if it's the answer. It returns rows with sex equal to men, but only shows the fare that they paid. So remember what I said a little earlier about selecting all the values where it's a row with male, and then we're only selecting the column that has male associated with it. So these would be all the columns where the men purchased a ticket for the Titanic. So I'll go ahead and select easy because I don't want to see that one again. This one already gives us the answer. Whenever you need to find the index of a data frame, what you do is you do .i lock, and usually I remember that by I is correlated to index, and then lock, which is location, and then we're going to go ahead and find the index location for the value 2, which would be 29. And if we were to show the answer, when we run the data frame, or like when we view the data itself, Titanic.head, we see 0, 1, 2, and it should be age of 29, but it's not. Wow. Okay, so that must have been wrong, but in essence, as we see down here, that it does shows 29. So let's go ahead and check the data frame for ourselves, like what would be the output. So we'd have nan 38, and okay, let's just do ilock then. iloc of 2. So it should be 30, and then let's go ahead and do df.age again just to see it, and then we'd see that it is 30 as well. So just remember, yeah, iloc will give you the index location. So I feel really confident with that, so I'll select good. We already saw this one, so I'm going to just select easy so I don't see it again. And then let's go ahead and see what this is. So what is the following output? Age.sort values, ascending equals false, NA position equals last, and in place equals true. So what this will do is it'll go ahead and organize all of the values. Like it'll sort all of our age values from oldest to youngest. So it'll be like 100, and then it'll go 99, 98, and so on. It'll go down in value. And then it'll place any null values, which are pretty much just like there's no value. It'll place those at the very, very bottom. And then we'll go ahead and do this in place, meaning we'll make it permanent. So let's go ahead and show it. And like I said earlier, we take the highest, oldest person, and then we just go down to the youngest person, and anyone without an age will be at the bottom. So sort values. I feel really confident with remembering sort values as well as sort index. So we'll go ahead and select easy. Honestly, I kind of want to just get to like left joins and whatnot. I'll do a few more before moving over to the joins because that's what I would like to hit for this video at least. So at least for myself, just to kind of go over them too. So what is this? So mask 1, no. I'm just going to select easy so we don't have to worry about that. Now when it comes to setting an index, for example, if we're able to set our index for year right here, and if we wanted to say replace it with sport, how would you do that? So what we could do is if we look at our summer data set, summer.head, we'd see that for our example at least, we don't actually have an index. So if you wanted to set the index, I think as sport is what I said, what we could do is we could do summer.setIndex and we go ahead and just select sport. And then I believe we'd go ahead and do in place equals true. And then we'd be able to see our index updated. So if we go ahead and run it again, we'd now see that sport was dropped in this column and it was adjusted over to the index. So if you ever wanted to do that, you can do summer.set or dataframe.setIndex. And now if we wanted to reset our index, what we would do is we do summer.resetIndex, if I'm not mistaken. How do we do that? Let's just go ahead and run it. I believe in place. We'll need to equal true though. So if we reran it, right. So now sport would actually no longer be an index, but it would now be a on the same level as all the other column names. So let's go ahead and move on to the next one. What is this doing? So this is an answer to one of the other questions, and because of that, I'm just going to click easy. But that was really good. It would have been a good question if it showed us the question first. So what does the following output do? So what is the difference between the two below? So if we're working with our summer data set again, and if we're working with nunique, what would happen is, like, what would be the output of, like, what would be the difference between these two in essence? Like, what do you think it would return? And I did mention this a little earlier as well. So when working with unique values, what it will do is it will take all the unique values. So for example, even though we have Greece up here 3 times, if we were to go ahead and say summer dot country dot unique, it'd return the number of unique values for this specific column, and it would go 1 for Hun, 1 for Ott, and 1 for Greece. And it would not count the remainder of these Greece values because it needs to be it'll be unique. So if there's duplicate values in a specific column, then it won't count the duplicates. It'll just count this one time because it's already populated. So what would be the difference between these two? We have number, or n unique, which is pretty much number of unique, and then also the length for athlete.unique. So when in doubt, always run the code if you do have it up, but otherwise we'll just flip the flashcard. So if you notice, both of these return the same count. So with this one, the number of unique, well again, it'll just go ahead and give us only unique values, and then it'll count the number of unique values that populated for our athlete column, which there would be quite a lot, as we see right here, because there's a bunch of different names for all the different Olympics. I feel like I should try to word these better though. So I'll click easy and we get to the joins finally. Okay, I think I'm just gonna focus on just the joins, try to make it fairly easy for whoever's watching, and in essence just kind of give my take on joins. So simply put, joins can be very difficult unless you have like a visual in your mind and you're able to kind of just comprehend like what's going on. So I wanted to bring up some additional help to like help understand what a join does and what it is. But in essence, this programming language is SQL, and this image is extremely similar to what would go on with our pandas vocabulary here. So in essence, what this is asking is pandas, which would be pd.merge, and now we're going to take our left column, and then, our left data frame, and then our right data frame, and they're going to join on subject ID, which is a specific column that they both share, and then they're going to be doing it as a left join. So I'll try to do my best to explain just what a left join is, and just if I was you, I would just focus on just left join for now. I wouldn't try to learn inner, right, outer, just focus on like a left join. So in your mind, picture two data frames. They both have similar column names. For example, the left has name X, the left has ID X, and then they both happen to have subject ID, right? And then those values will be the same. And now the right will have name Y, and the right will also have ID Y. Now what's happening is we're going to take everything that's on the right side where we have our subject ID. So for example, Billy would be 2, Brian would be 4, Bryce would be 6, and then Betty would be 5. But notice how we don't have a 1 value right here. So what's happening is it takes the entire data set, this portion, from the right side, the right data frame, and it moves left. So I think if you're watching this like on a camera, it might be going right, but just imagine going to your left. Everything just moves left because they're related right here. On the left data frame, they also have Amy, which is related to sub 2, Alan, which is sub 4, Alice, which is sub 6, and then A Young, which is sub 5. And all of these individuals here have the same subject ID on the left-hand side as these individuals on the right. So just kind of let that sink in. Try to visualize that you're taking the data itself and you're going to the left. You're going to the left. You're just going to the left. And just focus on really just focus on this specific value right here. They're coming together because they both have the same subject ID. So they're just going left. And then don't worry about the NAND, just try to visualize just Billy is correlated to Amy, Brian to Alan, Bryce to Alice, Betty to A Young, because they all have this same value. Now as a visual, again, hopefully this will be a little bit easier. Notice how there's ID and customer ID, and then you see how 1 gets correlated to 1, and you also have 3 which gets correlated to 3. And then you also have 4 which gets correlated to 4, but there's no 2. So if there's no 2 on that one, and likewise there's no 1 on this one, all that's happening is when it comes to joins, they find a common value, and if there is no common value on it going to the left side, then the value remains null. So there's no correlation at all between the two tables. So just take a minute, try to just like visualize that, and then yeah, just focus on the ones that can join, and then focus on the ones that do not join. So 3 to 3, 4 to 4, 1 to 1. And I'm emphasizing this because this will be an interview question for anyone that's new to working with data in general. For all of my interviews, I've had to answer what is a left join, and also what's the difference between a left join and an inner join, as well as, well, I'll leave it at that, but 99% of the time it's left join, and then they'll ask possibly another thing like how would you group the data together and then do a left join, or what's the difference between a left join and an inner join. And then some others would ask harder questions, but I'll just leave it at that. So just know what a left join is, and from there you can then focus on an inner join. And just know left joins can result in null values because there's no common ground on the left hand side. And not only that, when you're working in the real world, you'll see a lot of left joins. Only now am I seeing some inner joins, but everything I've ever really coded, I always go left join, mostly to try to avoid duplicate data as well. And I'll add some additional stuff in there as well when I'm building my pipeline. So I'll just stop with that, and then we'll continue like with pandas. So with regards to pd.merge, what's happening with .merge is we're taking the left data frame and the right data frame, we're joining on a common ground right here, and then we're going to be going left. And then if I was you, go ahead and feel free to like take a screenshot of this, or just go ahead and do like a quick Google search and you should be able to find it. So let's go ahead and see the answer. Well, that's kind of confusing, but in essence, yeah, I'll just stop with that because I think I've done enough explaining what it is. This flashcard could have been designed better if this question would have populated first, but just know you can join data together with pd.merge, and you'll need 1 data set and 2 data sets. So you'll need at least 2 data sets. Okay, so I actually kind of am cutting pretty much this thing, long story short, because 1, I felt that doing a left join would be a lot for any individual to take in that was new to this, and 2, I screwed up really badly on trying to identify how to locate 2 different values using modulo and the and sign. So I decided that I'm just going to kind of cut this video here. I'll go ahead and create other videos where I do use and modulo with .locate, but yeah, it's just taking too long. And I need to create more flashcards and likewise start creating some other things. So I'm going to go ahead and cut this video out here. If you enjoyed it, or if you'd like to learn more about joins, feel free to contact me and the link in the description for a Snugg session, or feel free to come to this website. I'll go ahead and link this website to, yeah, so it's just easy to access. But otherwise, I'll go ahead and end this video here, and I'll speak to you guys soon. Thanks.